AOQ stands for average outgoing quality. If you use a steady stream of something and you expect that embedded in it there's a certain amount of defects or defective, and so you sample this material as it comes in and you reject some of it, your average outgoing quality is the result of all that effort of sampling. Then on the other side of that, what is the general level of the quality of the material? Another way to think of AOQ is that it is in essence a formula that you use. It is calculated with a single formula. This particular problem is an excellent example of that. If a sampling plan used a sample size of n equals 100, I think we're going to need that, for batches of capital N, 1,000 units, with a 58.3% chance of accepting batches that have an actual proportion defective of 10%, what would be the AOQ resulting from this plan? So picture this. If you take in batches of 1,000 of something, and what you do each time you get a new batch is you grab 100 of them and you look at them, and you've got some sort of rule that depending on the results of that you either accept the batch or reject that. And in general, now wait a minute, the probability of accepting a batch is 58.3%, then fine. What's the result of all this activity? What's then the general level of quality of that stuff? All right, or here's another way to think about it. What's the formula that I need? Oh, well, the formula for calculating average outgoing quality is simply grabbing the probability of acceptance, multiplying that by, I'm going to write a lowercase p, but that is the basic actual amount that's defective, and multiplying that times capital N minus lowercase n divided by capital N. This is the particular formula that you fill out for average outgoing quality. Okay, so lowercase p, actually we can see that. That's the 10%. The uppercase n in quality control is always, the size of the batch, and the lowercase n is always sample size. So the only thing that we're lacking is this capital P for probability AC, the probability of accepting a batch. Right. PAC in this description is 0.583. It is that 58.3%. The P is 10%, which we remember in decimal places is 0.1, and it's stated right there, but I can write it again. N is 100, capital N is 1,000. So to calculate average outgoing quality, I just fill in the particular formula. Let's see. AOQ equals 0.583, right? That would be the PAC, times 0.1, that would be the proportion defective, or 10%, times 1,000 minus 100 divided by 1,000, or in the parentheses 900 divided by 1,000. Basically, this is going to be on my calculator 0.583 times 0.1 times 900 divided by 1,000, that's 0.9, or 0.052 is what we'll be showing on the display, which is to say 5.2%. The average outgoing quality in this particular case is 5.2%. Notice that the incoming quality is 10% defective. The outgoing quality after you're doing the various sampling is better. It's 5.2% defective.